Okay, the next one in this sequence of the 8 that we're going to do is pH3. We're going to use as our example. All right, so what's in the middle here? P. It has how many? It has 5. So easy enough, the 3 lone ones are going to connect to the 3 H's. Okay, now, how many bonded atoms here?
3.
How many lone pairs? No, that's 1. A pair is 1. So these 2, that's 1 lone pair. Okay, so 1 lone pair. Okay, so 3 bonded atoms, 1 lone pair. Okay, this is called trigonal, so triangle again, pyramidal, because it's going to form a pyramid. Before we had trigonal planar, but now we're adding a lone pair on top, and that lone pair forces them downward a little bit. What? There wouldn't be 1 dot. We're not going to get in that situation, at least not for what we're doing. Okay? All right, so how we draw this? Well, the P's still up top. Now, some people have you draw the lone pair, and I don't. It's just by convention, I don't either. But this basically looks like the bottom of the tetrahedral molecule that we already did. One's going to come out to the side. One's going to come towards us as a wedge. And one's going to go away from us as a dash. Okay, now if you see it with the dots on top of the P still, that's fine too. They do that to show that the dots, the lone pair needs space. Okay, in trigonal pyramidal, the bond angles are 107.3 degrees. Okay, and here's what it looks like. Okay, so it looks like a pyramid. It's not flat anymore. Remember the trigonal planar looked like a Y shape. Well, now we've added a lone pair, either top or bottom or wherever, and it's forcing them downward. All right, so on to the next one here, H2O. Obviously the most common molecule we deal with. All right, so for the Lewis structure, what's in the middle? The O, with how many? O has 6, right. Each H has 1, so easy enough, it's just going to connect to the O like that, and we're good. There's our Lewis structure. All right, center atom here, and you don't have to draw a circle around this every time. I'm just doing it to visually illustrate the point. How many bonded atoms? So 2 bonded atoms. How many lone pairs? Okay. All right, 2 and 2 is what's called bent. And why it's called that? Well, it can't be, basically, it can't be straight on still, it can't be linear because we have 2 lone pairs that need their space that are repelling as well, and that's going to force it downward. Okay, so what bent looks like is this, and you've seen this before visually at other times. O's here, H comes down, H comes down. All right, and our bond angle here for a bent molecule is 104.5 degrees. Okay, and it looks like this. It's back to being not 3D anymore. It's in one plane. Okay, so the last two we're going to talk about is where the expanded octet comes in, where we see we have 5 of something attached or 6 of something attached. All right, so the example we're going to use, ASF5. Right away I see a 5, I'm like, okay, that's expanded, okay, because it's going to go beyond the 8 for the octet on the center atom. So I know right away what's in the middle. The AS is in the middle. The AS has 5. So 1, 2, 3, 4, 5. Each one's going to connect to one of those F's. Okay, yada, yada, yada. Throw my dots in. Make it official. And again, I'm doing this sloppily because I'm in a hurry with it, but whatever. All right, so on the center atom, how many bonded atoms? 5 things attached there, so 5 bonded atoms. How many lone pairs? 0. Okay. 5 and 0 is what's called trigonal bipyramidal. Well, we know that bi means what? 2. So what this is basically it's 2 pyramids flipped upside down sitting on top of each other. Okay? So This is the only one also that has two different bond angles. Okay, and I'll show you why in a second here. All right, and how we draw it is as such. I got one up and one down. And one to either side, doesn't matter. I'll draw it to the left for this case. And then I'm going to have still one wedge and one dash. One's going to come slightly at me, and one's going to go slightly away from me, like that. And if you think about it, and I'll show you on the picture in a second, if you connected all these F's together, okay, what would end up happening is you'd have a pyramid sitting on top and a pyramid underneath it. Okay, and like I said, I'll draw it here in a second, but here's why you have two bond angles. The middle of this, okay, right here to here and to here is the same as our trigonal planar was. This is 120 degrees. But from right here to right here, or to the top, is 90 degrees. So it has both of those, 90 and 120. Like I said, it's the only one that has multiple bond angles in it. Okay, so looking at the shape here, looks like this. So what you see right here to right here to right here is your 120 degrees. Right here down to here, or down underneath my hand there, is your 90 degrees. That's where that comes in. Okay, those two different bond angles. Now, what I was saying before, let me get rid of these a second, is if I connected these. So I connect those, okay, I have a face over here I'm connecting, it's going to look like that. And then one here I'm connecting as well. There's one pyramid. If I do the same thing on the bottom, there's my other pyramid. So bipyramidal, two pyramids. Okay, that's what that means. All right, and then our last of these shapes here. Okay, we're going to use SF6. Again, I see it's bigger than 4, so I know right away it's going to be expanded. Usually these are easy to tell which is which. So S is in the middle of the Lewis structure, and it has 6 valence electrons, which are going to connect to each one of the F's. For time purposes, I'm not going to draw the electrons around the F. So I have how many bonded atoms? 6 bonded atoms. How many lone pairs? 0 lone pairs. Okay. This is called octahedral. And you'll see why in a minute when I show you what it looks like. So octahedral, how we draw it is like this. S is here. I got one up and one down. And basically, I'm going to have 2 coming at me and 2 going away from me. So the 2 coming at me are going to go just down slightly to the left and right. And the 2 going away from me are going to go just slightly up to the left and right as dashes. And it looks like that. Every bond angle in octahedral is 90 degrees. Okay, so octahedral physically looks like this. Okay, and I know it's hard to see here, but these are all 90 degrees. Why it's called octahedral, again, is this. If I connect all these faces, okay, I got one in the back that you can't really see, and then one to the side. That's 8. I'm sorry, that's 4. If I do it on the bottom, I have another 4. That's 8. We know oct means 8. Hedron in geometry means shape. Polyhedron, you've heard. Okay, so 8-sided shape, octahedral. Okay, that's where the name comes from. All right, so those are our 8 shapes. We just covered the 8 that we're going to talk about. There are more, but these are the ones that, you know, I feel are the most important and the kind of the easiest to memorize. You're going to have to be able to draw them. You're going to have to know the bond angles, things like that. Any questions on it? Okay.